So my name is Ron Evo. I'm the CTO of cPacket. And we want to talk about, OK, so this is cool. This is electronic trading, very specific. Every packet matters. But what do you do with the enterprise, right? So as we worked with electronic trading, we understood that these guys that monitor the electronic trading usually have a peer group that monitors the general enterprise, a lot more devices, much bigger environment. And then the questions came up, OK, what do you do with that? And there are other things that you need to care about. So this section will cover how the SysStore came to be and what does the SysStore do. So if you think about kind of the next thing is in enterprise applications is essentially enterprise applications. And we talked about electronic trading, right? So their quality matters, right? Every single packet matters. Latency is measured in nanoseconds. When you talk about a more generic case of an enterprise application, in the context of the zero downtime enterprise, it's more about every transaction. And every transaction means people don't care about retransmissions. They will care about latency, right? They will care about I cannot connect. So it's more about connectivity and latency. Now, just to, again, orient yourself where we're coming from, you have logs, right? And you have traces and events and all that. But when you talk about things that what we call the unknown, nobody's going to put a printf. So you're not going to have a log, right? And if you're looking for latency, you don't get that. Certainly, if you're talking about difference between 150 microseconds and 50 milliseconds, in some cases will cause authentication failure. So we believe that we have to start from packets. We acknowledge that you need to also melt, but this is kind of how we think about the world and what we're focusing on. So to give you an example, and I'm making my way to your question, to answer your question. So this is just an example where packets come into play and what are we going to do about it. So this is from one of our customers, a big hospital group. The nurses would come in the morning, trying to connect to around 8, trying to connect to their electronic health record, right? This is the system that includes everything. Effectively, it's a remote desktop to some server back in the data center. They couldn't do that or intermittently failed to connect. 9 a.m., things started working again. That's great. The day after, it came back again. So now the question was, OK, I understand the application. What I want to know is what happened, right? And you can think about it as different ways. So it started actually relatively easily in the sense that they knew that what they're seeing at the back end is that the latency all of a sudden at 8 a.m. is jumping to 300 milliseconds. The 300 millisecond caused authentication failure, which caused them not to be able to connect. But as you can see, the remote clinic was going through quite a few hops to get to the end, right? So it was going from a remote clinic to a colo to over SD-WAN. So the colo had a WAN optimizer, was going over SD-WAN to a data center. In the data center, and this is a little simplified, was going through a firewall, actually a couple of firewalls, into a VIP, into a load balancer. One of them was going to the authentication cluster. The other one was going to their electronic health record. So the logs.
Is each?
Yeah,
sorry to interrupt. This
no, go ahead.
Michael Winston again. Is each one of those monitoring points cap or a span or something like that? Because you mentioned before there's no agent, so I'm assuming there's some bump in the wire each time you have a MP or monitoring point.
Perfect. Yes. So all these monitoring points are taps. In this case, in this specific customer, they can afford, but technically that can be also a span or remote span. But in this specific case, they were all taps, right? So they essentially tapped all the important middle boxes on the way. So what they ended up doing is basically looking at the latency across the board, right? So using our packets, and we'll show in a second how we visualize the latency, you can go hop by hop, measure the latency, figure out at which point the latency jumped, and that's the one to blame. It so happens to be that up to this point, after the SD1, everything was great. And for whatever reason, the WAN optimizer was jumping the latency to 300 milliseconds between 8 and 9 for authentication packets it was not even supposed to touch. Right? Now, to your question, can I connect it? So there was a configuration there, right? So they knew, and you see in the demo, you have to label each monitoring point. So, we have customers that just see the VLAN and they know what the monitoring point is. Some want to give them names. But the dashboard essentially takes information about all the IPs, right? All the monitoring points, these are all configurable. And then the dashboard show you the labels. But in the dashboard, you still need to do the match on your own.
So in the product, can you say, I select the monitoring point near the authentication block, I select the monitoring point near the remote clinic port, and just say, tell me everything between these two. So does the central system know that there's a series of like 5 or 10 monitoring points, and then gives you kind of an end-to-end analysis?
Yeah, and we'll show that in the demo.
Cool.
Yeah, absolutely. We're going to just wait a little bit with the demo because we'll go for the next section. But yes, we'll show it.
One other question.
Yes.
Sorry about this. With all those monitoring points, how does the system handle packet dedupe without losing metadata for the individual packet, like latency, transmit time between each hop?
Perfect.
And wow, that must be a lot of storage for all those packets and a lot of back-end overhead to do all of that deduping and processing.
Yeah, perfect. So actually, we can dedupe, and we can dedupe in the packet broker, but this information, the latency information, is actually coming in from our capture analytics. And in this case, they ask us actually not to dedupe. They want all the data. And the way the packet capture analytics works, we use this VLAN information, and we have a trailer that we can add on the packet broker. But even if it's not that, we are able to see, okay, it's the same session. It showed up in multiple locations that we use the VLAN to identify and measure the latency for the same session in each one of these monitoring points. And the capacity we have, so today the Systor 100S, the one that can do 100 gigabits per second capture, we can do the analytics at the same rate. We capture, and it come all the way from 576 terabyte in a 4U device to 2 petabyte, if you want to add another 4U. So based on what's the average capacity that you need and how many days of storage you need, you can keep quite a lot of data, even in a demanding environment. And for me, the interesting thing is all these requirements that you guys are saying is, it was somewhat unfair when we had an ASIC. We could do whatever. When we go to analyze TCP sessions and latency, you have to have a lot of memory. It doesn't lend itself to new ASIC. So the challenge that we were facing is, okay, how do we do that effectively on an x86 server? And I think the solution that we used is essentially reimagining the core of the ability to capture packets, to analyze packets, and to index packets, such that we're able to actually provide all these metrics everywhere. So we have experts in networking, we have experts in storage. Many times the bottleneck is actually the storage, it's not the networking. You have to do that with zero copy. You have to be very smart on how you index and keep things around. And the reason I mention indexing is, again, more in the security case, but after you store these 2 petabyte of packets, someone calls you and says, okay, I saw some infiltration yesterday between 12, and it was 1,000 packets. And it was on a window of 2 hours. So the ability to go and find these packets is as important as the ability to store these packets. And in many cases, they choose us not because we're able to store, but we can actually find them later. So indexing, analytics, capturing, they all have to work together to deliver the solution.